Hello students and welcome to this calculus lesson. In this video, what we're going to cover is another example using derivatives and integration in context. So grab your calculators because you're going to need it in this video, and let's get started. So as I'm reading this problem, I'm going to note a couple things. We know that the watering tub, the temperature for the water in this tub is strictly increasing and is twice differentiable. I don't know if that's going to come in play, but I do know that those are important things to know. And we're given this information using a tabular format. So using the data in the table, let's estimate the value of W prime of 12 using correct, and then using correct units, we want to interpret that meaning. So I know 12 happens in between 9 and 15. So I'm going to estimate this W prime of 12, and let's see how we get this. All right, and my units for this, so WT is degrees Fahrenheit and in minutes. So we're going to get degrees Fahrenheit per minute. And so we want to interpret the meaning of this. Think about what we just found. We found a derivative and we know a sign. Because with derivatives, you always want to know whether things are positive, negative, or zero. So since we know that this is positive, we're going to say that the temperature is increasing from t equals 9 to t equals 15, which is already kind of stated in the prompt above. All right, so let's move on to the next part of this question. And it says, using the data in the table, let's evaluate the definite integral from 0 to 20 of w prime of t dt. And then we're going to interpret those results. So using this, we know that from 0 to 20 of w prime of t dt is going to get us w of 20 minus w of 0, which I can just pull from my table here. So w20 is 71 minus 55. So this comes out to be 16, and we know that this is going to be in degrees Fahrenheit. So since we're going up from a rate, we're going up to like a position. So this is how much change of the temperature has happened from t equals 0 to t equals 20, and this is accounted for in minutes. All right, so for 20 to 25 minutes, we know that the function w that has a first derivative given by this function w prime of t, we want to know what is the temperature of the water at time t equals 25. So here's what's happening, is that I don't have any information for this at 25. And so what I want to do is, okay, I want to figure out what this is. And I'm going to have to use some of the information given to me in order to figure that out. So what I'm going to do here is, I've been doing this in the last couple of videos, is I'm going to write out, okay, I'm going to write out my integral from 20 to 25. And I know w prime of t, so I'm going to write that in, 0.4 square root of t cosine of 0.06 t dt. And we know what this equals to. I know that this is going to be w of 25 minus w of 20. So we know here, again, I don't know anything about 25, but I do know what that 20 is. So I'm gonna end up using that. That's going to be 71. So I'm gonna have minus 71 here. And I'm gonna have w of 25. Well, in order to figure out this part, I'm just going to use my calculator again. So let's go ahead and do that. And the result that I ended up getting here was 2.0432. So 2.0432. So now I have enough information. All I have to do is add 71 to both sides, and we know that w of 25 is going to be 73.0432, and this is degrees Fahrenheit. So it does want to know what is the temperature of the water at time t equals 25, and we know that that temperature is being measured here in degrees Fahrenheit. So make sure that you always include units when you're given units. So that's going to conclude this video. Working with temperature, this is a very common free response question, very common things to do. So make sure you get this scaled down so that you can ace those free response questions. Of course, if you do need any help on any of these parts of this problem, please reach out to me. I'm Mr. Hernandez. This was Mr. Hernandez Teaches.